so for example, we have a paid promotion that we want our users to sign up for it, and we decided that changing the color of the button of the sign up page will make the users more attractive to sign up for the actual results. So, okay, so that's a simple comparison. So we just change the color of the text. So what do we want? So first of all, some terminology. We need to know the baseline conversion of our experiments. So currently we should know how much is our conversion rate. So we have 1,000 users every day and 10 of them are coming. So we can calculate 10 divided by 1,000 is going to be our baseline conversion rate. And why we are doing this experimentation? So we want our baseline conversion to grow at least 2%. So baseline conversion is going to be 0.10, and our conversion, that is what desired conversion change, should be 0.02. Just 2% increase among our users. So the main problem, the main target for A/B experimentation is first to understand what is going to be the measurable target for our experimentation. Currently, for us, it's going to be to increase the conversion rate by 2%. Without starting, I've seen in many use cases that people just run the experiment without defining what the metric is going to actually be to be compared. So this is quite wrong, because it's like having the data and then trying to find something there and just to have a winner because we want to have this change. This is wrong on mathematical side. So, for example, as I couldn't show anything on my company side, so let's just generate some data. So 1,000 users for A variant and 1,000 users for our B variant. In reality, these numbers aren't similar. They can be, the ratio can be even changed, 70-30, but it's good to know how we're actually doing the targeting. So when we are saying A, is usually in terminology is called the control group, and when we are saying B, so what we are actually comparing is the test group. So we just make some random generated data, so for 2,000 users, and we're just gonna assign them to A or B. So what variance they are gonna say. We'll talk about how to do the randomized assignment of experiments in production later. Before, just to have a mimic of data, how it's gonna be viewed. So okay, so let's tell also about them, whether they did convert in the variant or not. So the first column shows whether, for example, the user 0 with index 0 has converted and was in group B, and so on. So we have 2,000 users in this list. So the descriptive statistics of our user is going to be, so 90 users converted from variant A, 128 from B, and the conversion rate you can see on the last column. So actually, when we look at the conversion rates, we see that our desired 0.02 is actually exceeded, is 0.028. But is it enough to say that our second variant is good enough? Actually, no, because we don't have any confidence among our statement. If I can get another 1,000 users, maybe this ratio can change, and we can't even know what to conclude from this experimentation. That's why we're going to the stats. So if we get the distribution of our control group, which you can see is in the red, this red histogram. So we can actually conclude that our distribution is binomial because it's like a coin flip. So it's either there is conversion or there isn't. So that's why it's a binomial distribution. This line here is actually the probability that our the users from B actually could have been from distribution from A. So this line. Actually, as you can see, the line isn't here, so the most probable thing. So we don't have any good confidence among to say that it can be from distribution A. But this isn't enough to understand what actually is. But what if we just convert this line to actually a distribution? So the red one is gonna be about the distribution of A variant, and the second blue one is the second B variant distribution. So what can we say here? So we don't have apple-to-apple conversion, comparison, because the peaks of their conversion rates this is just the distribution of their conversion rates, and we actually can't compare. We don't know how many users there are, and what we're gonna do, we're gonna be again to the maths. So just to go back a bit to actually do the apple-to-apple comparison, we should remember what the Bernoulli distribution is all about. So the expectation of Bernoulli distribution is the probability, and the variance is the p multiplied 1 minus p. So we don't actually care now to go to the deeper to the stats, but according to the central limit theorem, if we do this experimentation many times, the distribution of sample means will be normally distributed among the true mean with the standard deviation equal to the standard error of the mean. So what it means actually is we'll have these two histograms here that are going to be truly compared to each other. So the axis of here is already converted proportion of them. And the dashed lines for each histogram is going to be the mean that I was telling about for the central limit theorem. So what actually this gives to us is we currently have these histograms that we converted by the central limit theorem, and here comes the hypothesis testing by its origin. So the red one, as before, is the A variant, and the blue one is the second variant, B variant, and some terminology also here. So the null hypothesis is that there is no difference among our experimentations. So sometimes we forget what the null is and what isn't. So for this case, the null hypothesis states there is no difference. So we did the experimentation, but we did see no significant change among the variants. So none is a winner. But the alternative hypothesis is there is indeed an improvement among our experimentation, and the B variant is the winner. So what can we interpret from having this chart to understand whether our blue line is better than the red histogram? So first of all, some metrics that are using to actually understand the performance of the experimentation. So is the chart visible for everyone? Yeah, so the green one is the statistical power, and it's calculated, it's a bit good. Can you see these dashes here? The gray dashes. Yeah, so they're red dashes which show the confidence interval for our histograms. So from stats we know that if we want 5%, 95% confidence interval, there's 3 sigmas. So it's this line for you see this green, and there is one from here. So the statistical power is the one that lies beyond the 95% and covers the alternative hypothesis, this green one, and it shows the statistical power. And the gray dashed lines, as I said, is the confidence interval for 95% for the null hypothesis. Statistical power is calculating, finding the area under the alternative hypothesis distribution and outside the confidence interval. If we go a bit more, so this line, so the one that is inside the, to the left of dashed line, but also under the alternative hypothesis, shows the ratio that we accept the alternative hypothesis and reject the this one shows that how confident we are to accepting the alternative hypothesis. And this one you can see here is actually the alpha. So this is the ratio we're truly eager to sacrifice how our confident we can be in accepting our null hypothesis. So when we set it to 5%, it's going to be the 95% that actually structures the boundary for confidence interval. So yeah, so actually this is what is actually done. So if it's better than the probability of 0.05, we do if it's greater, we do accept the null hypothesis, and it's less, so we do accept and conclude that our hypothesis is alternate hypothesis is better. So yeah, if we go a bit how it's actually this math, how it's everything converts to doing production. So some tricks from production, so product companies. So don't go overboard with segmentation. So for example, you have a recommender system that you only know that your audience is women. So you can show some men close to them and to try to experiment what to show to them. But if you go too broad and only show them men stuff, your experimentation won't be kind of valid. But showing only women clothes isn't enough, because maybe they're trying to show for their husband too. So this is some nuances that in production it's coming up. So you should always know what is your audience. So start big, then get smaller. So sometimes in production I've seen that they target their 20% of the audience, and they see no significant difference among the experiments, and they start to split all the experimenters by country, by gender, by every stat, just to see something in the experimentation. But this is wrong, because the kind of baseline to which the experimentation actually started is already not equal for them. Refine your segments. If you want to refine your segments, you should do from the beginning, not to split up from what you had a big experiment and then start doing. So doing the recency in your tests. Yeah, so some tests, for example, you are testing some feature, but you have many new users. So if you have many new users, you can't actually design there. If you have some feature hidden in the back of the application, for example, your new user's behavior can be actually triggered, because you have a novelty effect. Even for the existing users, returning users, having to see something, for example, too new. Actually, one of in the companies, I won't say where, so they were wanting to increase the call to action for a specific button, but one was static, some small button, and the other one they did this big, which had an animation of jumping bunny or something. So you can't do such experiments, because the validation for because the second variant was actually much more visible for the audience than the one that was just static and some static color and it wasn't visible. So this experimentation to have a call to action of the second button wasn't a relevant experiment. So segment by customer value. So this is a good feature. So in one of the companies, Facebook also has this approach. They are targeting their best kind of user segment. So for example, they are coming 15 days in a month doing these actions n times, and we want to kind of, they're our best users. So doing some experimentation with these best users actually can tell you what your best users do want, but if you mix them with them, the new users, you actually won't see the results. This is a good thing to segment. For example, if you are doing something core for new users, do it for only new users. If you are doing just for returning ones, just do it for the returning targeting. Consider geography and weather. So sometimes if you are a shopping online market and you know that for their geography reasons that some items aren't, for example, selling alcohol to Muslims isn't a good option to have an experimentation. So just consider user geographics and where they are settled and all this stuff. And focus on the why of the test, not the what. So many times I've seen in the companies, they say, just do all the experimentation, then we'll do all experimentation all the time. So this is, I think, isn't always a good kind of approach, because you're already slicing your users, and ideally your segments shouldn't overlap. But if you have many experiments, and each experiment, depending on your traffic, should have enough, for example, it should run 2 weeks, and you should always be cautious among how many experiments you are running. And as I said, you should know the target for what you are running, actually, your experimentation. And another thing I just remembered, but I forgot to add in the title is do you want to have overlapping experimentations or not? So doing overlapping experimentation, for example, just changing the color and the text of the button is already an overlapping experimentation. And this is a whole new story, so you should do multivariate A/B testing here. So sometimes they do change everything and want to compare with this approach. No, novelty effect is here and too many aspects are affecting it. So is it good to run several experiments simultaneously? Sometimes yes, sometimes no. So for example, if you are changing something on, let's take the product that everybody knows, for Facebook. So you're changing the icon for profile for the landing page that the user should target. And then you are changing something on the profile page to test the experiment, how it's running. Actually, you can do it if you do on the same segment of users, because they are overlapping. The same users has many experimentations on just running only for them. But if you do change something on the profile but something on the feed, maybe they don't affect it. So the user can participate in 2 experiments simultaneously. So when to interpret the results? As we were talking about the alpha and beta, so this is the sacrifice that we are actually eager to do to run the experimentation. So Evan, I like this calculator very much. So this is Evan Miller's A/B testing calculator. So this is the baseline conversion rate. For example, we have 20% conversion for this feature, and we want to see the 5% effect for our alternative hypothesis. So this calculator says, and here you can see that we have the statistical power that we're seeing in the histograms and the significance for 5%. So 5% and 80% is the kind of statistics kind of foundation. So this book conversion rates, the book alpha and beta that usually people start with. But if your product is too sensitive, you can set this up to 1% and have 99% of confidence interval to make sure that your experimentation is really the one that you want to change. So here, if we have 20% and 5% detectable effect, we just need 1,030 sample users per variant. But what will happen if I decrease the minimum effect? Who can say? The sample size will increase or decrease? Increase, yeah. So is this the touch? Oh, no. So if I said just 1%, 25, how much it should increase? So what if the baseline conversion rate is lower? Will it affect the sample size? If I changed it to 2%. To seeing 2% in 2% change, seeing 1% change is different than seeing 1% change in 20% change. So how you design actually your experimentation is gonna be decide when your experimentation is gonna be stopped. And so this is actually, if your traffic isn't good enough, so it can run for 2 weeks or not. So, and also some notes on when to run the experimentation. If you're doing something related, for example, to New Year, and it's a period of New Year, okay, you can do experiments among the New Year. But if you're doing some experimentation on generic, some feature, and you're doing push notifications and campaigns and increasing your traffic, this experimentation isn't going to be true valid because you have artificial flow, not artificial, but artificial for the A/B experimentation and not related to the experimentation itself. And coming back to just a second. So related to when to interpret the results. Whenever you have enough sample size, you should stop it. So do we need to revisit the already completed experiments? So this is a validation step. So sometimes people don't want to actually change, do want to change the variant, but they decided to keep the kind of initial variant because the experimentation wasn't good enough, and they want to revisit the already completed experiment and to kind of restore what the initial experimentation was, but this is quite dependent on how much traffic and load you can have, and this is a bit tricky depending on your product because you should have the same setup for your experimentation. What are AA experiments? So AA experiments, sometimes people do this experimentation before running AB experimentation. So this is helping to understand whether your experiment setup, technical setup is working. So if you see kind of the alternative hypothesis is winning in AA experimentation, which is the same variant, all two groups are seeing the same variant, but I don't know why the second group is actually performing better. So maybe your randomization or something is broken on this code side. Maybe you have a bug. So running AA experimentation will help you to understand whether your experimentation technical setup is actually working, and then to do AB experimentation just on the top of it. This will help you to eliminate the technical difficulties and kind of bugs on that side. Also related to randomizations, so some companies are using actually tools. They are buying, for example, Optimizely to run their experiments, but some are just building their tools themselves, doing the frameworks themselves. And actually, this is some tricky part in one of the companies. So they decided to, for each user, were assigned to a special number, which was the order how they're going to be participating in the experiments. So whenever one user were participating in the experiment and the experiment was stopped, he was always assigned to a new experiment. But the users which had a bigger number never actually participated in experiments. So their randomization of the experiment setup was actually buggy, so you shouldn't do such things. Every time you should check whether you want exclusive experiments, whether you want your users to overlap in other experiments or not. This is something to test so many times. To running with AA experiments, you will kind of test these buggy things to understand whether your users are always, or are this same segment of users always participating in experiments, the other aren't, or not. And yeah, so maybe we can head to the questions if you have one.
Thank you very much for a great talk. I have a question related to the expected increase of the conversion you mentioned. Since we for lower expected conversion, we need higher, the bigger sample, as you mentioned. Does it mean that we can stop the experiment earlier if we spot higher conversion than we expect?
No. You are kind of tweaking your experiment to see your desired result. So this thing should be done before running the experiment. Because if you're doing a big experiment, maybe you actually want the B to win. And sometimes I was saying that PMs, product managers, are always refreshing the dashboard to see, oh, new user came and they clicked this button, yay. So, but after a week, it just kind of slowed down. You can stop before you have the desired enough sample size. You shouldn't.
But you mentioned that we need, for example, if we put 5% increase instead of 2, we need the sample size of 5,000 instead of 25,000. And my question is, if we already have 5,000 visitors, and we already see the increase of conversion by 5%, that we see that it's according to the statistics.
I'm a bit skeptical to stopping it because the difference among this is too high. So what kind of experiment should it be to have this kind of increase? So actually the difference among the experiments, let's be frank, isn't this. We don't see this much change actually among the experiments to get this low sample size. Because if we are changing the color, we are changing the text, we can change many things on the page, and we don't run campaigns simultaneously. So actually, I wouldn't stop it.
So you don't trust statistics too much, right?
No, I wouldn't stop it. I like the kind of start. I believe in initial setup because it's always violated.
Thank you.
Yeah.
My question is also about the sample size, but I guess the more concrete question is, the sample size we calculate this way. What about the number of users to be used in A or B groups?
So this is per variant. So this is users current count per variant. So the total is going to be 50,000.
Oh, I see.
So per variant.
So you need this many people in each of the groups?
Yeah, for example, if you have 3 variants, you'll need 3 times this number. It's not always comparing A and B. You can have A, B, C, you can have A, B, C, D.
Okay, so let me put it slightly different. Suppose we have an e-commerce website, and we want to see certain page layout or suggest recommended products. And we take 2,000 users and we divide them into 1,000 in each group.
Okay, so
maybe not all 1,000 of them, or maybe not all 2,000 of them visit the site in the next month or 2. Are we okay with this, or how?
This is what I was talking about. What you are actually experimenting. If you're experimenting for your returning users, you should target them. So you should assign the randomized versioning only to them, not to all users.
Okay.
Yeah. So if you are testing some.
So that we get the numbers.
Yeah, depending on what you are actually testing. If you are testing the sign-up page, these are definitely the new users.
Right.
If you are testing something on setting page for profile, maybe they are actually the signed-up users, and I think some hidden page is gonna should wait longer to run because it's too many steps the user should do it to come there. And even calculating the conversion rate is sometimes too tricky. So you should always be cautious what the actual funnel for your user is. What's the beginning of the conversion rate, the baseline to convert is to calculate is more tricky.
Okay, in other words, just to put a point on it, I guess the sample size in each of the groups, do they all have to go through the experiment for you to conclude the experiment?
Yeah. So what is guns? For example, it's actually a trigger on the page. For example, I'm testing something on Facebook profile page. Until the user hasn't come to the profile page, the experiment variant is assigned to them.
Okay.
Yeah, so you come here, the trigger starts, and the action should be, I don't know, to add there is some photo section there. Do this action, the conversion should be compared with these numbers.
Got it. So then the user groups are not decided ahead of time. But they
Actually that's better, yeah.
Got it. Okay.
But depending on the experiment, if your experiment is starting from the beginning, it's better to decide the threshold where the experiment should trigger and what is the success rate, the success criteria for the experiment to be considered as a success.
Yes. How do you, in that case, ensure equal size, or does that not necessarily matter?
It's not always going to be equal to equal, but as I said, in a experimentation, you should see that the variants are equally considered.
The distribution option. Okay.
Yeah. Also, yeah, you can. I'll continue. You can tell them.
Yeah, I can just speak up. First, a comment and then a question. The question about stopping. There's a really interesting article. There's a really interesting article called "The Peaking Problem." I think it's from Shopify about how to or why it's so dangerous to stop the experiment early, and it's got really nice graphs that show it. And then my question was. Because we're starting to try some incrementality testing at my work, which is actually more what I would call this. And the best packages we've found so far is GeoLib from Facebook, but it's in R. This is a Python conference. Do you have other packages you could recommend for this?
Yeah, so actually we're building our framework ourselves. So maybe I can tell a bit of background and then come to your question. So currently in our company, we want to do our data science, machine learning models, experimentations, and we actually have a problem to define what is actually user here. So is it, for example, I'm coming from Service Titan, and we have technicians who go to the on-site and do some recommendations to their clients what should be installed in their house. So what is the user here if I have a recommendation algorithm here? So is it the technician's session? Is it the tenant itself for all his clients should always see the same? Or is it every time the technician is searching something? What's the experiment variant to be assigned? Actually, this is a huge problem to understand what is it. And referring to your question, we are building our framework ourselves. We don't use anything. Yeah. In my previous companies, the one was built from scratch and the other was using Optimizely. So external just tooling, and Facebook also has A/B experimentation, and Firebase also has it. So yeah, just even defining the user is not user session, what is it? It's quite difficult to truly understand when should it be. And we're in discussion, so whether it should be the technician session until they log out, kill the application, or it's just every time they search, or for all employees for this specific client should see the same experimentation. So it's in B2B, it's more harder to do than in B2C. So I come from PixArt, so there are many millions of users coming every day, so you can just segment some part of them, and they're gonna come. So the flow, the application is popular, the users, statistically, if you have many, the population is quite big enough, you can have some confidence in the results. But if you're B2B, and into B2B, for example, in our product, employees are getting trained. Even having employees being trained is how the whole segment of the tenants' employees are going to behave the same. So how to do it? So even that kind of stuff is really hard actually to do.
Thanks for your great presentation.
I can see. Okay. Sorry.
Before you start your A/B testing experiment, do you have just selection, random selection with high size is enough, or do you think you need kind of track other KPIs? For example, you want to launch a button or maybe a landing page, and you want to compare, two group of users. Do you, for example, compare their logins or maybe other performance in advance, or not? Or just
so usually we compare some metrics, but only one metric is considered as a winner for the experimentation setup. I've seen many times that they are calculating 10 metrics, and when in one metric they see significant difference in the experimentation, say this is the winner. No, it's not. Yeah, it's kind of cherry picking the metrics with the one that you actually do want, and just to make sure that the variant you do want is a winner. I have even seen that the CEO said this variant should go, we're just stopping the experimentation. So why did you run the experimentation in that case? So this is just a waste of resources, because this user, if someone wants, the other PM wants to run an experiment which should be only exclusive, so this user shouldn't participate in other experiments. So you're just taking the user from the other product that should test something on them.
Thank you.
Yeah.
No more questions? I have a question. Thanks for the presentation. I was wondering, how do you deal with small amount of users coming into the test or control? So if you can't wait this amount of time, like if you have 10 days and the product says that you need a minimum amount of time, how do you do the quick decision besides like having the minimum of the product?
Yeah, you shouldn't do it, A/B experimentation in that case, because the product shouldn't tell you how long the experiment should run. This is math.
How can you minimize the amount of time that you need to wait if you have small amount of flow into coming into
Yeah. Which approach? Yeah, Bayesian approach is more kind of more. I like that approach more. So.
But do you use it? It was the next question. Do you use Bayesian statistics?
This is gonna be included in our framework to decide how we're gonna actually for each model we're gonna decide. So we don't have this problem of common users, but Bayesian approach is much more understandable, because if you tell the PM I have 95% confidence interval, confidence that this is, but the PM doesn't understand what is your 95% of confidence. The Bayesian approach is much more easy to interpret and easy to understand. Yeah.
Thank you so much.
Thank you.